Hello and welcome to our presentation about linear approximation and differentials. We are from Group 10. There will be Regina, Stasia Sita, and me, Keisha, as the speaker of this video. For a brief explanation, linear approximation is a function of x. It is for calculating things approximately if we don't have a calculator. So the formula is linear approximation equal f of a plus the derivative f of a times x minus a. For example, we wanted to find the linear approximation of a square root of 80 when the function is equal to square root of x. To solve this, we can choose 81 as the a because it is the closest number to 80 that can have a value of 9 if it has a square root. Second, we can determine the derivative of the function, which is 1 over 2 times square root. And the third, we can fill the formula, which is the linear approximation equal to square root of 81 plus 1 over 2 times square root of 81 times x minus 81. Then we can solve the square root of 81 as 9 plus 1 over 18 times x minus 81. And the last part, we can substitute 80 as the x of the function, so we can have 9 minus 1 over 18, which is equal to 8.94, repeating as the answer.
For the problem and solution for the linear approximation material, for the question, find the linear approximation of the function fx equals 3 root x3 at a equals 27.
So we need to find the fx, or we can call it Lx, which is the linear approximation, then equals fa plus f prime a times x minus a. So first, we need to find this and then this one. Okay, so the first one I want to find the slope, which is f prime a. F prime a will be d divided by dx. We use this one. So x squared 1 per 3. It will be 1 per 3x, 2 per 3. It will be minus because 1 per 3 minus 1 will be minus 2, 3, like that. We need to fill in this a with this number, which is 27. So f prime 27, 1, 3, 1, 27, 2, 3. So it will be, so this will be 1 per 9. So f prime 27 will be 1 per 27. We need to find the fa. It's easy to find because we only need to put the 27 inside the fx, or fa. So it's 27 equals 3. Then we can find the linear approximation, which is the fa is 3 and plus f prime a will be 27 x minus 27. So x per 27 minus 27 per 27. 3 plus x 27. I want the L to be 9. L9
Equals 3 plus 9 divided by 27. 3 plus 1 per 3, or
let's use linear approximation to find an appropriate value of the square root of 17. And here's what we have. We have fx approximate to fa plus f prime of a times x minus a. So what is this a value? The a value is going to be just a value that is close enough to an actual precise value we already know. In this case, I'm going to pick 16 for the a, Why is that? Because I know that the square root of 16 is equal to 4. So our a should be 16, and what shall we do next? So first I'm going to write fx equals to root of x. Then I will take the derivative of this prime x, and I can bring down the exponent. We have 1 over 2 times minus 1 over 2, which will give me 1 over 2 square root of x. And let's continue. So I should be having f, which is 17, approximate 16 root plus, we're going to have this one, 2 the root of 16 times 17 minus 16, which gives us approximately 4 plus, it will be 1 over 8, and then 17 minus 16, which will give us 1. So 17 approximate, so 4 plus 1 over 8, which will give us 4, 1 over 8.
I will give brief explanation about the differentiable function. The definition of differentiable function is that you have this function that y equals fx. Let the dx be an independent, and then we define the dependent variable, which is dy, with the equation of dy equals f prime x times dx. If you divide it in both sides with dy divided by dx, and then f prime x times dx divided by dx, it will be this equation, and it's called differential form. So that's the definition of differentiable function that we will discuss. For the calculating differentials, find the dy and evaluate the following function at x equals 3 and dx equals 0.1. We find this function, which is y equals cos x. First, we find the derivative of fx. The derivative of fx is f prime x, like this. And cos x will be minus sin x. After that, we plug the derivative, this one, into the differential formula. We put this function inside the differential formula, which is dy equals f prime x times dx. So it would look like this, dy equals minus sin x times dx. After that, we use this and this inside the function of the differential formula that we already put the minus sin x in. So it will look like this. So for the differential will be dy equals minus 0.1 sin 3.
So we were asked to find the gradient where x is 8. We need to differentiate. To be able to differentiate, we need to prepare it. So I'm going to write, let's write x 2/3 plus x as power of x and plus x. And now we can differentiate by dy over dx equals to 2 by 3 minus 1 by 3 plus 1. So we need to substitute 8, but I'm going to rewrite that with the power back down on the bottom, which will be 2 over 3 x plus 1. Okay, now it's written like that. We can substitute 8 and the third root of 8. Which is 2 root 8 plus 1. And then we're going to be having 2 over 3 times 2 plus 1, which will make us 1 over 3 plus 1 equals to 4 by 3.
For this one, find the general solution to the differential equation, which is dy divided by dx equals x squares plus 10 divided by 3y squares. The first step, we will change the location of the 3y squares to the other side. 3y squares t times dy dx equals x squares plus 10. After that, we use integral to find the solution. Integral x squares plus 10 times dx. It will be like this: 3 per plus 10x plus c. We can eliminate the 3. For that, we find the y will be x per 3 plus 10x plus c. Then y will be 3 plus 10x plus c. That's the solution of this question.